these, which represent your energy levels or start of your energy levels, right? These are your periods. Those are the energy levels that are happening, or the starts of the energy levels. Those represent what we call periods. That is the pattern when things start to repeat, right? We had seen before that you had a red, and then when you went all the way across, the row, and we started the next row, it started with another red behavior. So every time you're in this row, you've started a new energy level, and that element has the same behavior as the element of the previous row. So it's a periodic repetition. Now, that creates columns, which all have similar behavior, right? All the atoms in this column, they all have similar behavior. So we're going to call that a group. They're also sometimes known as a family. So this is your group, sometimes known as a family, because they all have similar behavior. So we have group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 groups or families in the periodic table. And so now I can ask you, you're kind of like, what's that game, Battleship? Right? I can say, hey, what element is in the third period and the 17th family? Right? So, okay, well, third period, 17th family, that would be the intersection here. So whatever element there, I believe that's chlorine, would be there. So we can identify just by a grid system where elements are. Okay. And again, remember that these two are parts of the 6th and 7th period. That would also, and they are not part of the family, so we don't give them, they don't have a family number because they're totally, they live here. They don't have any family numbers associated with those elements. The other thing we needed to notice, and I erased them all, but what we can do is we can split this up into like kind of areas. All these elements in here, they were all the elements that ended in 1s or S1 or S2. So these are going to be your S block elements, right? Because this ended it with an S1, S2. This was S1, S2. Remember, they went all the way down. So they're your S block elements. Over here, all of these elements, these were all of your, what we call P block. They all ended in P's, remember? SP, P1, P2, P3, P4. So these are your P block elements. Now, what's interesting is, because helium here was a 1s2, this is technically, and this is an exception, this is still technically a little bit of an S block. So really, this should have been here. But chemists decided to put it over here for different reasons. We'll explain later. That means that this, because it's got the 10, it's got the 10 elements across it. Well, that's your D block, right? That's where all the D electrons were living. And then, as we just discussed, down here, That's your 14 elements all the way across. That's your F block. That's where all your F electrons live. So your periodic table is split up into regions because of electrons. S, D, P, and F blocks. Of course, helium being a little bit of an exception. So that's important, so knowing where and what regions of the periodic table have what electrons. And then the last piece that I want to go over, aside from the groups or families, is, and this is a very big deal. This dividing line here. This is the dividing line between what we call metals and nonmetals. Next class, we're going to go over what's the difference between a metal and a nonmetal. But over here are the metals, and over here are the nonmetals. Now, what we need to understand is there's a couple exceptions here, of course, because it's chemistry. That's terrible. Okay, the metals I'm going to shade in blue. So all of these, most of these are metals. Okay. So all of these and even these are considered what we call metals. And right now I just want you to know the regions. We'll explain the difference between metals and what we call nonmetals later. So these are, I want to write this like I used to do in high school in my notebooks. Except that I want the marker so thick. In my heavy metal writing, I'll put an umlaut over a T, which is completely illegal. But those are my metals. Metal! And then along the dividing line between metals and nonmetals, we have some of these guys in these boxes. And they're called our metalloids or our semimetals. So they're kind of not metals, they're kind of not non-metals, they're in between. They're, again, metalloids. That's terrible because of the thickness of my marker. Or sometimes they're called semimetals. And then this, this last piece here, these are what we call our nonmetals, because they're not like metals. And you can't read that, of course, but let me write it on the side over here. Okay, there are nonmetals. By the way, this element down here, a little blue. Okay, so you can see that most of the periodic table, are metals. 2/3 or 3/4 of the elements that we know of are all metals, and then there's what we call nonmetals, and there's a few along the dividing line. Which are, or again, what we call metalloids or semimetals. Oh, there's an exception, of course, over here by the metals. Hydrogen, let's see. Hydrogen is not a metal. it is a nonmetal. And again, this is a situation where, you know, instead of helium being instead of helium being over here, maybe hydrogen should have been over here. And so those first two elements are somewhat problematic when we try to classify things. Regardless, they are where they are, and there's reasons. But we have to understand there are metals, nonmetals, and metalloids. We need to know their location. We will talk about the properties of metals versus nonmetals and metalloids, like I said, next class. Okay? So that was a lot, but I hope you can rewind and rewatch if you need to follow along. And we'll continue with more next class. Thanks. I did forget to make mention earlier on when we were talking about electrons and electron configurations about something something pretty important. When we look at this, I'm going to get rid of a lot of all of this. I'm going to move this for a minute, groups and families. But when I look at this, we learned earlier that everybody in actually last chapter, we learned that everybody in this particular group, this family, had one valence electron. Everybody had one valence electron in this group, which now makes sense because all of our electron configurations are exactly the same. That means that everybody in that first column, first family, first group is going to have one outer electron because the electron configurations are the same, or pretty much the same. That means that in this next column, family, everybody has two valence electrons. Now, we don't do valence electrons for 3 through 12. So we don't do. But when we jump to the 13th column, 1, 2, 3 valence. That means everybody or any element in this column has 3 valence electrons because, again, the electron configurations are very, very, very similar. And then that means in this column, everybody is 4 valence electrons. And everybody in this column is 2, 3, 4, 5 valence electrons. And that means in this 6 valence electrons. And that means in the 17th, 7 valence electrons. And then everybody in the 18th has 1, 2. Well, I did it the wrong way there, didn't I? Because I have to go around the correct way. 8 valence electrons. The exception to that, of course, is helium. Helium can't have 8 valence electrons because helium only has 2 electrons to begin with. So this is the exception. But if you know the group number, the family number, you know how many valence electrons that element has, right? If it's in the first group number, it's got 1 valence. If it's in the second group, again, it's got 2 valence. If you're in, now skip 3 through 12. We don't do those because those are D block electrons, and the D block electrons, they don't behave, so we don't do valence electrons for the D block. But in the 13th group, we do not 13, but 3 valence electrons. In the 14th group, we do 4 valence. In the 15th group, we do 5 valence. In the 16th group, we do 6 valence. In the 17th group, we do 7 valence. In the 18th group, we do 8 valence, of course, except for our exception, helium. And again, if you have the same valence electrons, you have the same outer electrons, you're going to have the similar behaviors. And that's why you're in that particular column, in that family, in that group. Okay? So hope that helps.